function block has an interface in which we can provide a place where we can pass information in from the outside, out from the inside, and also references that can make use of data that's stored in other locations. In addition to that, we also have a space that we can declare information that is retained by the instance of the function block. So that's not shared between function blocks if they're used more than once. That's relative only to the instance that we're creating now. Now, that might not make sense straight away, but it will when we cover the next section, which is creating an instance of a function block. So for now, just keep that in mind. And this top area here, where we have this table, this is where we declare our data for our interface and also the data for the function block instance. So I'm just going to go ahead and expand this because we're not interested in the code right now. And here we have our input. Now this is information that's going to be passed into our function block from the outside. So from wherever this function block is called. So something that's worth noting is that function blocks must exist in an OB or in another function block in order to be called in the program. So this is how we pass information into our function block from somewhere else. So if I give this a name of input1, we can choose a data type, and every data type is listed in here, even custom ones. And we'll just leave it as a Boolean for now. And we'll also have input2, and we'll declare this one as a real, so a numerical value with a floating point. You can put comments here. So this one we'll call bool1, and this one we'll call real2. Now, this information will be copied from the outside to the inside. And that might not make sense right now, but you're not working with the information outside of this function block. For example, if we put a variable on the interface to this, it's copied into this block. So if we change it inside the block, the outside version doesn't change. It's only the inside version that changes on this symbolic reference here, input1. Whereas outputs, if I call this output1 and we make this a Boolean, the same thing applies, that we set it on the inside of the function block and then pass it outside or copy it outside. If anything changes after we've sent it to the output interface, it's nothing to do with this function block. And this function block will just remember that we set it to true if it is passed to another variable outside and that gets set to false later on. It's still true inside this function block until the logic sets it to something else. And again, that will become more obvious the more we use function blocks and also in the instancing section of this lesson. I'm going to create an output2 as well and call this a real. And again, you can write comments on here if you want to. So I'm just going to call it output1 and output2. And then we have in-out. So in-out is a special interface where we pass by reference. We don't copy. So if we pass something on here, such as in-out1, but we make this an array 0 to 200 of real, that's a very large amount of information. We can see that there is a lot of it here. However, what we're actually passing to our function block is not all of that information. It's not copied. We're just passing a reference that says this is where the actual data is stored, and you can work directly with the data. So for those that have done other forms of programming, passing by reference, passing by value, in-out is passed by reference, input and output is passed by value. So you copy the values in and copy them out, but in-out we pass the reference or a pointer to where the actual information is. And where I touched on, if we copy something in from the outside, it's only affected inside the function block on these variables. That is not the case for in-out. If we change it inside our project, or inside our function block, sorry, it is affected in the original location. So that's something to bear in mind. but in-outs are very, very useful, especially when working with large data that you don't want to keep copying, or that's information that's shared between function blocks. Here we have our static. Now, our statics are information that is relative to this function block instance only. So if I put in here static 1 and also static 2, make that one an integer. When these are written to in our function block, they are only updated in this function block instance, but every instance of the function block will have this data. Again, this will become more apparent when we actually look at the data that's generated for a function block, but it's important to note that if you have 5 instances of this function block example and you change static 1 in the first instance, it does not update in all of the instances. It's only in the instance relative to the data that you're working with. Down here where we have temporary data is exactly the same as what we saw in our OBs. So when we came up to the top of OBs and we had temp here, and I explained that if you write something in an OB, it's not remembered between scans because temporary variables are not sort of stored between scans. Function blocks are exactly the same. They're not stored between executions of the function block. So if I wrote in here temp1, if I set this temp1 to true, it would only stay true until the function block execution has finished. And then the next time we call the function block, the temp1 will just be temporary data again available to be written to. And the reason I say it's not initialized or it's not set back to false is because it might not be. It's really, really important with temporary variables to initialize them. Otherwise, they could have information in that you're not expecting. For example, this temp1, currently right now, we obviously have no logic that's writing anything. However, if we were to download this to a PLC, go online and have a look at this information, you might find that it has a true value in it. And that's really confusing for people, especially people who are new or don't understand what actually happens with temporary variables behind the sort of scenes in a PLC. But this data that's in temp1 is not guaranteed to be safe, initialized, or false, have a default value until you first write to it. You'll notice that statics have a default value that we can set. So do inputs and outputs. So every single time that this function block is scanned, scan the first time for these ones because they're retentive between scans. So this will have a value of false. This will have a value of false as well. And 0 and 0 the first time that they're scanned if nothing's passed into them. These statics will have false and 0 if nothing's set in them. But the in-out, which is a reference, can't have a default value because it's a reference to some other data. And a temporary can't have a default value because its location in memory is not defined until it's called. So it's up to you to make sure that you actually initialize this data or run the risk of it containing something you're not happy with it containing. So with that being sort of mentioned, it's important to write to a temporary before you read from it. Contemporaries will be covered in more detail as to when to use them and when not to use them as we go through the course. And finally, down here, we have constants, which we touched on in OBs as well. If you have a constant and it's set a value here, such as 5, this constant cannot be changed in runtime. You can't write to it, you can only read from it. And it's a good way of using it in things like maths calculations, where depending on where you're using the function, you might need to change the constant, but you don't want to give the opportunity for somebody to change it in runtime, or setting global constants and reusing them around the project. So that is our interface set. And now that this is set, you'll see that we can access that information in our logic. So if I type input, we can see input 1. And if I hover over this, it tells me that it's an input. It's coming from our input layer. And if I write output, you can see output one's available. And again, it's coming from the output layer. And what we'll also see is if I write static, we can see static 1 is available because it's a Boolean and we're using an instruction that only accepts Booleans. And basically that means that right now, without going into the logic, because we'll cover this stuff later, if our input 1 is turned on outside of this function block, so whatever we're passing in here, if this comes in as a true, we will turn on our output and pass that out of the function block, but we will also turn on our static inside the function block, and it will remain in the function block's instance data. So in the next section, we'll have a look at how this interface looks when we create an instance of our function block. Just remember that what we're doing right now is setting the sort of template for how our function block is to interact with other things, excluding the logic, which is obviously how the function block will actually operate at a logic level. But everything up here is the blueprint for data. And in the next section, we'll have a look at how that is sort of displayed when we use it inside something else.